So we start. It says many triangles are not right triangles, but rather oblique. We've been down that road. We were able to use the law of sines to solve most triangles. But what about triangles where we have, say, all three sides are given, but no angles? Or what about two sides with an included angle? Here's the idea. In order to use the law of sines, you have to be given an angle and its opposite side. What if we don't have an angle and its opposite side? Which brings us to the case of side, 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 or side, angle, side. So what do? We use the law of cosines. So let's set it up. Here's what it looks like. We'll drop an altitude. We'll make it h. We'll call this A, B, and C. What is the entire length on the bottom? C. We'll divide up into two pieces. We'll call one x. We'll call the other one C minus x. Very good. Now the idea is I would like to write an expression, say using angle A. I have side A over here. I have side B over here. As you look at this piece, I want to write another type of relationship, different from the law of sines. And this time, I'm going to be using this x and this c minus x. So I'm going to write down one expression right now, and we'll see what you guys think about it. I'm going to say that x squared plus h squared is equal to b squared. What do you think? Why? Pythagorean theorem, right triangle. I'll write down another one. X c minus x quantity squared plus h squared is equal to a squared. Still like that? Now, we have two problems here. We've now related the two triangles together with two different variables that they have in common, which would be h and x. I would like to get rid of those because in normal problems, we don't have h, we don't have x. We don't know those lengths, and so we're going to get rid of them. So what I'm going to do is this. I'm going to make this equation look like h squared equals b squared minus x squared. I'm going to make this equation look like h squared equals a squared minus parentheses c minus x quantity squared. So what did I do in that step? I made them both equal to h squared. If they're both equal to h squared, they are equal to each other. B squared minus x squared equals a squared minus parentheses c minus x quantity squared. So I've done a pretty good job there. I've gotten rid of all of the h's, right? H's are gone. Now I need to get rid of what? The x's. Well, let's FOIL it out and see if those x's might cancel. I have b squared minus x squared equals a squared minus parentheses. What do you get if you square out c minus x? What are we going to get? C squared minus 2cx plus x squared. I'll distribute my negative sign through. B squared minus x squared equals a squared minus c squared plus 2cx minus x squared. Let you catch up, and we're almost done. Almost. What do you see? X squareds cancel. Add an x squared to both sides, they go away. So what's the only thing left I need to account for before everything's written in terms of a, b, and c? This x right here, right on the 2cx. I could write an expression for x in terms of A, B, and C, or the angles, that would be very helpful. And then I would be done, and I would have a formula that relates all three sides to each other. So let's go back up, and let's look at that side x. This side x right here. As we look at angle A, side x, is it the hypotenuse, the opposite, the adjacent? What is it? It's the adjacent. So which two trigonometric functions, sine, cosine, or tangent, deal with an adjacent side? Cosine and tangent. Well, tangent is opposite divided by adjacent. I don't want to use h again, do I? But cosine would be x over b, correct? The cosine of A is equal to x divided by b. That's a nice piece to be able to use. In fact, I'm going to write that down here, and I'm going to make use of it. We said that the cosine of A is equal to x divided by b. And I need to insert something for x. So can you solve for x here? What do you get? X equals b cosine of A. We've done it. We got rid of our x. I can now take my b times the cosine of A, and I can put it right here. Now the expression will need just a little cleaning up, but we have everything we need. I have a b squared on the left side equals a squared minus c squared plus 2 times c times b, or b times c, times the cosine of A. Now I'm going to make this look a little bit nicer. And you're going to like it when I switch it around just a little bit here. I'm going to just have a squared on the right-hand side. So on the left-hand side, I would have a positive b squared. I would add the c squared over to both sides, so I'd have plus c squared. And I would subtract the 2bc cosine of A. So look at what I get. A squared equals b squared plus c squared. Almost, what does that almost look like? The Pythagorean theorem, right? It almost looks like that. And in other ways, we can write it like that. It's going to look familiar to you. The only thing different is that we subtract off 2bc cosine of A. That's it. And so what does that mean? Well, look, if you want to find side A right here, if you want to know what A is, you're going to take b squared plus c squared. So you're going to take this length plus this length squared minus 2 times bc times the cosine of A. So you're going to work with these pieces right here. So again, look, if I want to find that, I use this stuff right here. Side, angle, side. If I want to find that, I use this side angle, side piece, and I can solve for it. Look at your cheat sheet that I've given to you. They write the formulas in 3 different fashions. The first one is the one that I derived for you. All the rest we could derive the same way, just change around the variables. It says if you want to find side A squared is b squared plus c squared minus 2bc cosine of A. Or b squared is a squared plus c squared minus 2ac cosine of B. Or c squared is a squared plus b squared minus 2ab cosine of C. And we could even manipulate the other way. Here we're solving for a, b, or c. If you wanted to know an angle a, b, or c, just given all 3 sides, then you could use one of those formulas. And so we get to choose what we want. And so these formulas are ones that you should get used to. And when we set up this very first example, which is all we have time left for today, you will see how this works out very nicely. Law of cosines, we're not going to write it down because you already have it on your sheet. So let's write down the triangle right now. It says solve the triangles given the following conditions. I sketch a triangle. A, B, and C. A is 26 degrees, B is 12, C is 15. So this is the type of problem you'll have on your test. And as you see it, you first need to diagnose which of the 6 cases is it? Angle, 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 side, side, side. What do we got there? Side, angle, side. Why can't I use the law of sines right now? It's much simpler than the law of cosines. Why can't I use the law of sines? Because you don't have a opposite side. We would need angle A and side A to use the law of sines. Got to have it. Well, I don't have it. I have side, angle, side. And my cheat sheet tells me right up at the top here, it tells me that what I need to do is if I have side, angle, side, use the law of cosines. So that's what I'm going to do. I'm going to use the law of cosines. Which side should I try to solve for? Should I try to solve for side B, side C, side? I should solve for side A. Because once I have an opposite side, say side A, then I can start to use the law of sines. So that's the whole idea. Let's get an opposite side, then we can use the law of sines. Which of your 3 formulas would you like to use? The A squared equals, B squared equals, or C squared equals? A squared. So it says A squared equals B squared plus C squared minus 2BC times the cosine of A. That's our formula. So it's time to start plugging in the values. What's A squared? We don't know. What's B squared? 12 squared is 144. Plus, what is C squared? 225 minus 2 times B, which is 12, times C, which is 15, times the cosine of A, which is 26. I could just plug that all into my calculator. 144 plus 225 minus 2 times 12 times 15 times the cosine of 26. When I type it all in, it gives me A squared. A squared is 45.43. What do I do to find A? Square root both sides. Whoop. Second square root. Clear. Second square root. Second answer. And we get 6.74. So I can start to set up my triangle. A, B, and C. Little a, little b, little c. A is 26 degrees. Side A, 6.74. Side B, 12. Side C, 15. Now, I'm going to tell you guys something. We're going to build off this tomorrow, but I'm just going to caution you, okay? Remember yesterday when we came up with, 2 different solutions? Remember when we did that? You can, if you're given side, angle, side, you can always avoid the possibility of 2 solutions. There is only one solution, trust me. But some people end up coming up with 2 different ones, and we should not do that, okay? Here's how you avoid the 2 solution problem. Work with the small side next. Don't work with the large side. Work with the small side. The question is there an obtuse angle out there? There might be. If there is, we won't. So you already found it, Devin? Okay. If you found it because you worked with B first. If you would have worked with C, you would not have come up with an obtuse angle, and it would have been wrong. Okay, and I could show you why that happens tomorrow, but right now I'm telling you, we are going to force the obtuse angle out. And how we do it is we find B first. What can we use to find B? That's correct. What can you use to find B first? Law of sines. And what'd you come up with? What? Somebody got it. 51.3? Now we are going to force, I mean, there's no option for C now, right? I mean, C could be, you know, it's like, is it in the first quadrant? Is it in the second quadrant? Well, we're forcing it to be obtuse right now because we're going to subtract these from 180. And so that's going to show its true colors. It is truly obtuse. And what is it that we get? You got a 54? Should we? I'll come check your work, Sam, but this is where we want to build off of. So your assignment is to finish up the stuff from yesterday. Tomorrow you will have an assignment. We will do this case tomorrow where we're given all three sides but no angles. All three sides but no angles.